Hope you all had a great lunch and you're ready for a very engaging panel. My name is Nilu Salehi. I am co-founder and CEO of Across AI. I was also a professor at Berkeley. And we've put together a really great panel of folks who are doing a range of deployments of agentic AI as well as cutting-edge research on it. And agentic AI is the hottest word right now in AI, so really excited to dig into it with these folks. We have about 45 minutes for this panel, and we want to make it interactive. So about half of that time, I'm going to ask questions from the panelists, and then we're going to open it up for your questions. There are 2 folks with mics, so please prepare your questions, make them spicy, and we will get to them. So I'd first like to ask our panelists to introduce themselves. Dee, we can start with you.
Oh wow, okay. Hi, I'm Dee Yang. I'm assistant professor at Stanford University in the computer science department. I work on large language models and human AI interaction. Recently, I have been thinking about how to build an AI scientist and also improve coding agent. We are also very interested in how the future of work would change with AI agents, specifically how we can actually use AI agents not only to help us automating work, but also augmenting human capabilities in work, research, and well-being.
Hey everyone, I'm Sandeep Uttamchandani. I'm the VP of Enterprise AI at Palo Alto Networks. In the Enterprise AI Charter is very exhaustive. It's really about how AI can transform the way work gets done across every business function, across every aspect, be it the AI for coding to AI for marketing, sales, legal, GTM, you name it. One of the things, and again, in my experience, I've been in this space for more than 25 years, worked at various different companies. We were just talking before this panel started about our PhD days. And my PhD, I went to University of Illinois, Urbana-Champaign. I was building an AI expert system where the intent was, how do you take machine learning models and use constraint-based optimization to make the system think, right? So it was more on the symbolic reasoning side. Things have come a long way, so it's just so exciting with everything that's going on, and we're really transforming things at Palo Alto using AI.
And good afternoon, everybody. My name is Ed Chi. I'm a VP of Research at Google DeepMind. Previously, I was in Google Brain working with Sammy Banjo and many of the luminaries that might be in the audience today. My work at Google DeepMind, some of you may have read Chain of Thought. That was one of my papers. And then beyond that, my team built Lambda, which turned into Bard, which eventually became Gemini. And then beyond that, I've also worked a lot on recommendation systems, personalization systems. And then since you were telling about history, maybe just as a historical fact, I got all my 3 degrees at University of Minnesota, and Jeff Dean and I took the same AI class where we both learned about neural networks back in the early 90s. So interesting. Fun little fact. Yeah.
Hello, everyone. I'm Rama Kiraju. I lead the Enterprise AI Charter at NVIDIA, VP of Enterprise. Sandeep pretty much summarized what I do at NVIDIA. My mission is to bring AI to every corner of the company, all transforming and reimagining the way we do our work in all aspects of our company: supply chain, sales, marketing, finance, IT, chip design, software coding, and all of those. That's what I do, building platforms and building AI agents and bringing the community together. Prior to joining NVIDIA about 3 years ago to take this role, I was an IBM fellow at IBM and was part of the IBM Watson division and IBM Research and helped build some of the core functions in the IBM Watson product platform at that time.
Thank you. Super excited to have you all here. Thank you for joining us. So I wanted to get us started by asking, there's not a startup or company out there who isn't building agentic AI these days. So what is it really? How is your organization getting value from it, really? Because there's a lot of noise out there, and I would love to hear what has worked for you? Where are you seeing value actually being produced? And anyone who wants to take that question can go for it.
I can start.
Please.
Well, let's start with ChatGPT, which was the advent of generative AI, right? Where you are able to now process with large language models and understand what's in your intent, and also understand and generate summaries from large documents and so on. Agentic AI takes it to the next level, where these agents are able to plan, reason, perceive, and act and autonomously, and also learn autonomously. So that's what, and they have agency, and that's why they're called agents, because they're able to act independently in doing all of those. And I would say, if you look at a simple AI workflow, LLM workflow would be you give it a prompt and it executes it using an LLM model. An agent is a more complex one where you're trying to solve a bigger task, and you have to plan out what tools might be available, given that tools that are available, how to really invoke those tools to put the whole overall workflow together. So it's actually a system. And it might involve retrieval, it might involve re-ranking, it might involve rephrasing queries, it might involve vector databases, it might involve just invoking a bunch of automations with tools and so on. So it's a complex system, and that makes it a lot more challenging to manage, to improve, to observe, and a lot of things. And I hope we'll talk about all of those things in the course of time. Yeah.
Thank you.
I guess you haven't given me the wink about being controversial and being spicy, so I'll start by being spicy. I actually think that one way to think about agentic AI is a step backwards, in the sense of what we have been trying to do in this space using sequential transduction is actually to try and build a single model that can do everything, right? I mean, that's the whole idea of the whole scientific endeavor. But what has happened in the meantime is, as we actually want to bring this technology either into the enterprise or into the IT or into the consumer world, we were realizing that these models are still not reliable enough. And so what needed to happen was a way in which we go backwards to system sciences, if you will, to use system science methods to control this technology so that it can become more reliable, to increase its reliability, to enable us to control it in a more direct manner, right? So that we can program it in some way. So all this things that have been happening with agentic AI to some extent is going from single agent to multiple agents so that we can use system science, all the things that we used to know in computer science to actually engineer these systems. Now, a lot of people, therefore, as a result, get really excited because it was kind of like, a lot of people who didn't get a chance to actually work on one of the large models, all of a sudden says, oh, I have something to do. I know what to do with the stuff I used to learn, in school, and then all of a sudden all this stuff applies again, right? From distributed control to scheduling to all kinds of older algorithms that all of a sudden become relevant again in this agentic world. I think that's one of the reasons why it has really exploded this year, agentic AI, is because now it, in a way, plugs the gap between when the moment AGI arrives versus now where we have to make it work for an engineer a real system. Not spicy enough?
You're getting there, but you can dial it up. Please, Sandy.
So I'll kind of make it spicy. I think it's a step forward.
No, backwards.
and I'm going to basically put on the hat of driving outcomes, right? So I'm thinking at this as, how do you harness the value of AI? So it's a step forward in harnessing the value of AI. And let me explain why, right? When you think about the journey, if you go all the way back, we started with recommendation systems and the early days, right? Then came LLMs or generative AI. Everyone started having a lot of fun with generative AI. What we quickly realized is that it didn't know your enterprise-specific data. So it had limited value. Then came LLMs, LLM workflows with RAG, the whole evolution there. What you quickly started realizing is that, well, now they understand the context, but it's still a single model, right? When you think about really the aspect of intelligence, in my mind, LLMs is one form of intelligence which is similar to humans, right? Where it's learning from patterns that are provided. This is where the next step here with agents or agentic coming in, the reason I think it's a step forward is now you're not just thinking about LLM or LLM plus RAG, go solve the problem for me. What you're really looking at is how do I bring in different models, different approaches, right? There could be a Bayesian approach here. There could be a constraint optimization approach here. This is the beauty, right? You're defining a goal, you're defining tools, you're defining constraints, and letting the system kind of define that. So in some sense, if you think about more from an applied standpoint, it now makes it more useful for a much broader set of use cases. Now, it's a different thing to think of the last mile. It made the last mile even more difficult when it comes to observability, context building, trust building. So I know we'll figure out the answer for that. Maybe that will continue the next conference as a topic as well. But that's where I stand. I think this is the right step in the right direction.
Okay.
Dee, no pressure, but you're the tiebreaker.
Yes, I need to cool it down. I already said some spicy here. I will start with I think a lot of the agent scaffolding will become less relevant moving forward. So by that, I mean in a relative long term. In a short term, I think these days we are still doing a lot of agentic improvement to make the agents work much better for the local context by doing a lot of design, tool selection, or just the entire kind of workflow setup. A lot of those improvements seem to be quite useful today in terms of performance improvement. But I think with stronger single model as the base, and also with more mature end-to-end optimization, then this kind of scaffolding is going to matter less and less. However, at the same time, I feel like we are not utilizing a lot of the data very efficiently right now. So we are trying to build a coding agent for some of the Swiss-ish tasks. And one thing is that you just really need to leverage the limited amount of trajectories that you can get from coding agent. And this actually is not a new topic that we only face today. If you think about even a few years ago, when we first had systems like BERT or other systems, how to leverage this kind of limited data was a very important topic. So thinking about synthetic data or even data augmentation, this kind of perturbation to really leverage this kind of small data to train agents, I think in a short term is still very relevant. The second thing is actually going back to memory. I think many of us probably have the painful experience that those agents don't work for your tailored context. The reason is that because they don't know you. They don't know that your writing styles. They don't know what type of things you like. They don't know that you always start to, you always have this particular way of interacting with systems. So how can we actually build a very powerful general user model that really get to know you? This is different than the search history, different than my listening history of music, different than my browsing history. It could be everything on my computers. So this is actually something we have been recently thinking about, that is, how can we actually turn everything we are doing on our computers into a memory to better scaffold agents so that they really understand the context. There's no definition of context. Everything will become context. And then the last point I want to mention here is now we are seeing so many kind of agents go into daily workflows. How human can actually collaborate with agents is becoming a really important topic, even more than before. Automation is one way to go there, and I think automation will happen for certain type of task, but not every single task would benefit from automation only. So how to think about how human can actually collaborate with agents to do task, teach agents to know when to defer to humans, when to ask clarification questions, and then truly do this kind of smart delegation of tasks at a fine granularity between human workers and AI workers are going to be quite critical.
Thank you, Dee. So one thing I'm observing is quite a difference between people who are thinking about what is it going to look like in 10 years and people who are trying to deploy these things in enterprises today. And I've seen both sides of it. I come from a research background, but one of the companies that we work with at Across AI has 13 different Salesforce instances. And the rules for who should see what account in what Salesforce are so complicated that they have 100,000 territories defined that just decide who should be able to see what in these 13 different databases. So yes, context and memory for sure is a huge part of it, because without that, the agents don't learn, they don't get better over time, they don't actually end up being that useful. But when you actually go to deploy something at a large enterprise, there are all these challenges to scale, to security, to actual reliability. So I'd love to hear from you all, where have you seen the biggest challenges in actual deployments, and what are some strategies that are seeming to work?
I can go. You've highlighted many of the challenges. The first one I would say is getting the governance around your data right. So let me give a concrete example on that. At NVIDIA, about 2 years ago, we built one of the first chat agents at the time to answer questions for employees on our intranet page. And it had a roadmap to automate tasks and other things. And we were quite excited. The accuracy was pretty good. We were about to launch it. And then we were going through our security reviews. Suddenly, the security team discovered that this agent is now so powerful that it is going across so many different kinds of documents in the enterprise. And there were some documents that were incorrectly shared, overly shared, basically, sensitive documents. It's not that the system was not honoring the role-based access controls. It was doing all of that. But even with that, people make mistakes and overly share documents, right? And that was some of our chip design documents and such, which are highly sensitive. And the system was able to answer questions on that. So and these kind of things really then brought a halt to that whole project. And then we collectively started thinking to say, well, we have an opportunity here to now take this agent and actually help our security teams to detect overly shared sensitive documents and take proper precautionary measures to secure those documents and then release this responsibly. So those are some of the kinds of challenges that you encounter. Yes, we encountered many other challenges, like all the control points when you build an overarching, a chat agent or a system like this. How do you make sure the metadata of the documents is right? How do you make sure that the retrieval accuracy is right and relevant, and the rephrasal accuracy could be wrong, and you need to tune that, and re-ranker should be right. The citation systems accuracy, if you just take a simple RAG workflow, retrieval augmented generation workflow, there are so many control points that you need to tune, and there are so many places where it could fail. And you need to tune for all that. And we did all of that. And those are all challenges, practical challenges. But even after that, then you have to think about, when it comes to deployment, all of these kind of things. Then another aspect, so enterprise security governance is an important one. You put these systems in production, people start giving feedback. How do you securely capture that feedback? Because people are asking sensitive questions about mental health related questions. They're asking questions about maternity, paternity leave before they inform their managers. They're very sensitive questions, and they need to be compliant and stored in a secure manner with PII redaction and all of that, especially as you're taking that data back to build the data flywheels to continuously improve the pipelines, right? Because the whole point of these AI workflows, they're 100% accurate. You don't need to worry about it, but we all know they're not. They hallucinate, they make mistakes, and they need to learn on the job based on the mistakes they make and the feedback that users give. So you need to take all that data and feed it back to improve, and the improvement itself has to be applicable to various stages in the pipeline, because it's a system, as you were pointing out, and there are many control points, and where to improve in order to improve the overall accuracy is a big challenge. But before you can do that, you need to make sure that you are securely saving the content and redacting it so that your security teams can give approval for you to use that data to either fine-tune or to prompt tune, whatever the case may be. So these are some of the practical challenges that enterprises run into when you're trying to deploy, agentic AI solutions. And then now other examples. You build MCP servers these days, Model Context Protocol servers, for pretty much every tool that can be made available to an agent to call to construct a complex workflow. How do you make sure that those MCP servers are secure, first of all? And how do you make sure that these agents are inadvertently calling some of the APIs that could actually end up writing, right? You could do read operations, that's fine, but if they're doing write operations, you have to be very careful because they could be completely altering the system. So securing and managing all of those things is another big problem, as you're now starting to expose many of the enterprise APIs to these agentic systems to autonomously act and take action and perform various kinds of CRUD operations. So these are all some of the practical challenges to deal with in deployment. And not to mention the monitoring aspect, right? To measure to look at the traces, the logs, and analyze not only for accuracy but also for various kinds of security threats, jailbreaking kinds of scenarios, and out of context and hallucinations and so on. So many tools are required for really agentic systems to work effectively. It's not just about getting the best LLM model that can give 100% accurate answers. Even if it is as close to that as possible, the whole system has to work effectively for the whole solution to really be effective.
Thank you.
I'm struck by, as Rama was describing this, I'm struck by the following, which is like in knowledge work and in IT and in the enterprise for a very long time, we have been trying to some extent, engineer the system with the human in the loop so that workflows, et cetera, become more automated and more deterministic and more efficient and more, all these big words that we would like to have, right? But then the reality is that, we've heard this story so many times before, that when databases were invented, we were going to automate everything in the enterprise and in the corporate space so that it would be really easy. Well, how many of you feel like your expense reports are truly a lot easier than, say, 10 years ago? Why is it still so inflexible? Well, because we try to engineer these systems by rules. And then now we ask these agents to follow the same rules. Mm-hmm. But actually, I think maybe this is why I'm maybe inserted onto the panel to be spicy. But it feels like we're going the wrong way in the sense that the whole reason we wanted AGI, that we wanted these truly, why we are calling it agentic and AI, is because we want not just deterministic decision making, right? It's just before I came up here on the panel, somebody in the audience asked me, a lot of the problems that we ran into in enterprise processes are in fact, things that people set down a bunch of procedures and then rules, and it turns out that these rules conflict, right? Don't take a flight. So I'll give you an example that I've run into in the enterprise a lot, right? Like you're going on a trip, and then they say, this is your budget for going from San Francisco to Milan, let's say, for example, right? And then, employee inevitably has some sort of exception, right? Like they need to stop by Zurich first before they go to Milan. Now, what is the travel cap? What am I allowed to spend? What if I wanted to go there to see my sister for one weekend? Now I'm going to pay for the hotel myself, of course, but can I just, no, you can't fly to Milan first and then take a side trip and blah, blah, blah. Just all these kinds of exceptions that happen, right? So rules never cover all these cases. And so then humans become interacting with this really inhumane system, right? And then you have to call up somebody, can you make an exception? Then you got to get a VP to approve. And this is what enterprises end up spending money on. It's crazy that you end up having to get a VP to approve a travel budget that was $500 extra. Is it worth their time to look at that? No, it's not. But because we got to follow the rules and it's inflexible, blah, blah. So, I think in the future, what we should have, now this might become spicy, is truly a decision-making system that's designed by humans, used by humans, right? Like these kinds of agentic enterprise systems should become more human and not more automated and more deterministic and more, just better of what we already had 20 years ago. Still not spicy enough?
Could I comment to fight it back?
Please.
Okay.
Go ahead.
So actually, I think I agree with you on we should not design rules, but what should we do? I think there is this term from social science called prescriptive versus descriptive. Prescriptive means that we are going to design rules, norms for people to follow, for agents to follow. And I think this is one engineering thinking of how to build systems. Another is descriptive. And this is actually something I feel a lot in the last 2 years. With Gen AI, sometimes I feel like I'm not expert at all. People who use these kind of tools, AIs, they use it for work, for coding. They know it the best. They know how to best work with this kind of tools, etc. Maybe another way of building AI or better agents here is to think about how can we actually observe how people are doing things there, and then from a descriptive, adaptive perspective to build it. So to me, I think this will make a lot of the kind of prescription a little bit go away. But this actually triggers more questions like what Niloufar asked is, we don't have privacy, access control, and a lot of this kind of components built in. So as a process, you have a lot of messy kind of leakage of privacy and other kind of things. But I think it's this kind of uncertainty and also adaptive that make today's agentic systems even more exciting. Like, how can we actually really get it to automate some kind of task? For reimbursement, I never want to work on it. But for other kind of tasks, like talking to people who are helping with this, I'm very happy to. So I think it's going to be a spectrum if we think about should we build it for humans. Some tasks we should just let agents do. Some tasks I want to have more agency. I'm
really glad that you mentioned that, and let me respond briefly.
And then I'll be the media.
And then you'll be the, because I'm surrounded by two people who are working more on enterprise AI, but I personally actually work on personal assistant, as in the consumer space. So hopefully many of you have seen the videos of Project Astra from Google. So that's one of my teams at Google. We're working on building Project Astra. And my mental model for this is truly like a personal assistant. It's like we're taking the LLM and essentially taking them to butler school, the way you want to think about it. Like, you're going to spend $150,000 to hire a personal butler, and you expect really high-level assistance in decision-making, right? Things like, for example, if I said, I never like taking early morning flights because I go to bed late, right? Now a personal butler learns about that. But then if there's a special reason, let's say, for example, but if you take the 6 o'clock flight, you'll get into Phoenix, Arizona early enough so that you can play 18 rounds of golf at 2 o'clock, and I've already booked the tee time for you, and the clubs are rented already. All you have to land is get into this Uber, whose number is 340, and then you'll be there on time for your 18 holes. And then I'd be glad to wake up at 5 o'clock in the morning, right? So that's what personal service is like. That's what not following rules, but understanding the reasoning of how you want to live your life, understands your values. That's humanistic AI. And we're not there yet if all we do is deductive reasoning. So we need to get out of that, yeah.
Okay, here's the verdict. We are making it spicy for the sake of spiciness now. I think bottom line is, looks like we are saying the same thing in different ways. Essentially, yes, there's going to be a shift in how systems are going to interact with humans. Currently, it's rule-based. That's exactly the point, right? When you're thinking about getting agentics into your enterprise and into your products, it's all about, is it ready today? Where is the scaffolding? Where are I would say, the nuts and bolts to make that happen? I think in my mind, there are two aspects to this. First, as Rama was mentioning, we are rolling out these systems. And again, to give a practical example, similar to what Rama mentioned, right? At Palo, we have an internal assistant, a digital assistant, that can essentially be that one-stop shop, right? And one-stop shop for any employee to come in with questions to HR, IT, finance, travel, and so on. And it's evolving towards becoming a universal agent. So what that basically means is that it's blurring the different systems you have. If you look at different systems, different offerings, they're nothing but systems of record, right? And the key really is, as a user, why should I have to interact with these many different systems, bring them together? I should be able to talk to one thing that's knowledgeable and evolving into that direction. So I think from a vision standpoint, the trajectory is there. The question really is the how, right? And there are maybe 2 or 3 different ways of how could play out. One, maybe, Ed, your viewpoint is why can't we get there sooner? Which is, why can't we rely on the autonomous reasoning the agent can accomplish? So any of this can be seen as a workflow. Instead of a human giving the workflow, give it the goals, give it the constraints, give it the tools, the agent figures it out, right? That's option 1. Option 2 is more of, I would say, a deterministic workflows, which is, in some sense, the RPA style workflows. Someone defines the steps. Someone knows that these are what has to happen. The problem there is the brittleness. The long tail of workflows or scenarios that workflow cannot handle has been the classic problem. But it's deterministic, it's reliable, something you can verify. I think in my mind, it's not going to be either or, it's some combination of the two. And maybe going back to your point, which is, it may not just be the extremes. Depending on the use case, you may decide to do something very deterministic, which is a repetitive workflow, very well defined, continue to leverage it, continue to have the right building blocks, and maybe you can take steps which tend to break or brittle and bring in an LLM, bring in a reasoning, but it's still in the context of a deterministic workflow, right? To the other extreme, complete autonomy, I think we are definitely a few steps away from that. Not because whether the model can solve the problem, whether the model can maybe get the task done. It's more about how would you know? How do you monitor? How can you reliably say that this is going to be the case no matter what input is provided, right? This is where software engineering differs. In traditional software engineering, more contained, you can build these test cases, so on and so forth. So the biggest challenge, if I were to pick one, and going back to Rama's point, she mentioned about the whole idea to deployment. There are many aspects which can derail outcomes. One key thing, at least if that was one takeaway from my side, it's context engineering. That's the thing we need to get right. We need to think about what's the context being provided, and more importantly, context is not a one-time, I give the context, we are done. Like even in that digital assistant example that we're talking about, how do you reliably make sure that the information it feeds on is accurate? The information about HR policies, it's garbage in, garbage out, right? So looking at context engineering from a technology, but also people process technology, you have to think holistic. And this is something that we actually recently did, where when we launched this, we realized these things were getting out of date. And we actually built a feedback loop, a feedback portal that allows system owners to know what data is getting outdated. LLM as a judge flagging responses which are below par, causing the right updates to happen. So I think we have to think really from a systems thinking standpoint in terms of how to get AI reliably deployed.
Can I share one example?
Please.
Ed, you had a very interesting, provocative stance, which is actually a very good way to think about it to push the envelope. I do want to share from a practical perspective.
Just trying to be spicy.
No, that's great. It's a very thoughtful way to think about where the future should be and how we should push the envelope. I want to share a couple of examples from a practical perspective in enterprise context. What happens when you give agency to these agentic systems? My experience has been that the answer should depend on the use case, as Sandeep was saying. I'll give two examples. One use case that we work on is talk to your data use case, where planners, finance folks, whoever, need to interact with these structured data systems in natural language kind of way, and they need to get their insights. Traditionally, people build dashboards of some kind with different kinds of SQL rules and all of that to get what users want out of it. For executives, planners, different kinds of users. The requirement in that case for when you're talking to your data is that the answer has to be 100% accurate. You cannot make up numbers because you're retrieving data and it has to be exactly, give the right answer. When you say, what is my revenue forecast for this quarter, it has to really pull it from the revenue forecast that's in the system. It can't add 100 million more or less and hallucinate, and we cannot rely on that. So in that case, it better be highly accurate, and non-determinism is not acceptable. But there are other cases, say in our supply chain domain, we build interactive what-if scenario planning kinds of solutions for our supply chain planners. So they are doing different kinds of what-if scenarios to do demand supply allocation. People are asking for our NVIDIA chips, and there are our customers and suppliers, contract manufacturers, when we're trying to do the supply and demand matching. There, we have to have so many what-if scenarios. What if I allocated more to this customer versus this customer? What if this gets delayed? There, I want more of that non-determinism, as in explore different kinds of example scenarios and present me with different kinds of alternatives. So yeah, it depends on the use case. In some cases, you just want it to be accurate, and for that, you have to build all the scaffolding, everything, all the measures, guardrails. In other cases, it's okay to let it loose a bit. Even so, you want it to be accurate, of course, but you let it to explore a little bit more.
Thank you. We have a little bit of time for questions, so as you prepare, or whoever has the mic, one thing I'll note is that it's fascinating that we started the conversation about agents, but a lot of the problems that came up were actually people problems, telling us about stupid things that people do, and then I'm not really sure if it's good for agents to do that as well. And then all of the systems that we've put in place for people to be able to work in these organizations are now going to have to change. So our first question from the audience, please.
Yeah, another people question. In this network of agents, what role do humans play in the future? How do you see the human in this network as a value-added agent?
Interestingly enough, Dee and I were both originally trained in the HCI area. So there have been, as I mentioned at the UC Berkeley Agentic AI Summit, in fact, a lot of the early agent work were done in the combination of old school AI, symbolic AI, and HCI field. Luminaries like Patty Moss at MIT in the 90s really studied these questions of agency, and to some extent the question that you just asked, Rama. It's fascinating that the word agency and agent are right next to each other. Yeah. And yet there's been very little study, especially in the new agentic AI era, as to what do we want to do about this. It reminds me a little bit, by the way, when Rama was explaining this, of the differences between industrial robotics and general robotics that's happening right this year as well. So I would say if you think about 2022 as being the year of pre-training, 2023 as being the year of post-training, and then 2024 as being the year of RL, and then 2025 as being the year of agentic AI. And then the other thing I would mention about 2025 would actually be the rise of general robotics. And the difference between general robotics and industrial robotics is very close to what Rama mentioned. In industrial robotics, for example, pick and place very classic thing, right? Like you want the circuit board at this orientation with this tolerance of 1 millimeter or even 0.1 millimeter precision. Like imagine you're doing chip design or a chip manufacturing. Even 0.1 millimeter is not good enough. They have technology that can go all the way down to 0.001, et cetera, right? That kind of reliability, that kind of repeatability is not good enough to be 99.99% reliable. They want to be 90.9999999% reliable. But in general robotics, we're talking about something else. Like I don't know how many of you, I'm sick of all this talk about AGI when I don't have a robot to clean my house and cook and fold my clothes for me. I don't need my t-shirt to be folded with 0.001 millimeter precision. If it's folded and placed in my closet, it's good enough, right? And then even if it occasionally puts the yellow one with the white ones because it was too dark or something and it didn't quite get the color right, I can probably live with it. It doesn't need that kind of reliability. So it turns out that the huge advancement that we're making in robotics right now is in the area of general robotics. Now I can say things like, hey, that water bottle at the front of the stage is really annoying. Please pick it up and throw it away. General robotics can do it now. We're getting to a point where we could do that. So this is a great advancement of planning, of understanding the world, of doing things approximately and things like that. That's where really AI is making a lot of progress. So the issue about agency is very much related to Rama's answer, which is what reliability do you want? And where in examples of what Chris Manning was just describing this morning, for many years we worked on NLP where we wanted to develop summarization technology, for example. Now, what does it mean to be accurately summarized? That's also very, very difficult. But most people, that's show a raise of hand. How many of you at this point consider, like there are too many research papers to read, right? How many of you use Gemini to help you read research paper at this point, or Notebook LM? A decent amount, right? Like, would you say summarizations is a solved problem? Maybe you wouldn't say it's a completely solved problem, but many of you say it's good enough, yeah? That's the idea of general robotics is kind of like that. It's good enough.
Maybe if we can add to the role of humans more with an example, right? When you think about AI for coding, there's clearly a lot of talk that AI can code, and what is the role of an engineer going to be? Now, if you look more closely at the information, you can think of greenfield and brownfield projects, right? Greenfield are quick demos. Of course, AI can start, iterate, can do it very fast. When it comes to brownfield projects, which have been around for years with lots of decisions, lots of context, a lot of information, this is the part where you want to make sure humans are involved heavily to ensure, because one of the things with AI is that it can actually rewrite things, like its decision making to rewrite. And there are very funny examples, right, where to get a test to pass, if it is not passing, it can do things like, okay, return true, which is it'll always pass in those scenarios. So what you really want is to make sure are the things being followed? And this is where humans will play more of managers of AI, orchestrators, coordinating things, but eventually the buck stops at the human. I think there is a reality where it's complete AGI. I think this is going to be more, even in that world, how do you really ensure things are what you need? So I think humans have a role to play.
I want to add just one quick thing.
Dee has a paper on this.
Yeah, so actually I have a course on this
Oh, not just a paper.
That's your short answer.
I was actually super nervous of coming to this BayLearn event because I was like, oh, I need to learn more about enterprise AI, etc. And I'm so glad that the entire conversation converged to human plus AI. So this quarter, I'm teaching a course at Stanford called Human-Centered AI. Actually, I need to head back to teach it later today. Going back to your question on human, we have...
Yeah, I'll take the class.
Yeah, you should all stop by.
I'll come with you.
Yeah, so basically, we recently did this work called The Future of Work with AI Agents, where we interviewed over 1,500 workers. If AI is going to be really beneficial, then it shouldn't just be computer scientists, software engineers, or these highly profitable jobs. It should benefit every single occupation. So we talked to over 100 occupations, over 1,500 workers, and get to know like in what ways they want their task to be automated, in what ways they see issues, etc. We found a very interesting patterns where actually over 46% of the tasks, workers themselves want them to be automated. I was very shocked by these results. But you can also see today's landscape of AI capability and worker desire. So we were able to illustrate there are some kind of tasks where AI is ready, human want automation. Some of them, AI is not ready, but workers want automation. Others is about AI is ready, but human do not want automation. More importantly, related to the question you asked, I actually worry about this a lot because we teach students. What skills should we teach students today? All my homeworks can be solved by ChatGPT. And how should we think about the students' over-reliance, critical thinking moving forward? One of the other findings from that work, what we see is that there is going to be a shift of skills that we have. So some of the skills that are highly paid today, actually the top one paid skill is analyzing data and information. And a lot of those skills. Moving forward is going to be around prioritizing, organizing work, training and teaching others. So like professors' jobs are somewhat secure. And then also like communicating with people. So you definitely see this kind of potential shift of skills. Even when Sandeep mentioned about like human will be managers of agents, etc. This is actually about prioritizing and planning work. So there are lots of this kind of nuances. And I think this is actually one of the big challenges we have today. In addition to building agents, how could we make sure humans still have the essential skills to survive in this world?
Thank you. And on that note, that is all the time we have today. Thank you.
Thank you.